Aloha. I am Professor Stephen Pike, Assistant Professor of Marine Engineering at the United States Merchant Marine Academy. Today we're going to do an introductory lesson. There's one a little bit more basic on YouTube, but this is an introductory lesson for using your thermophysical properties and some of the other tools in Engineering Equation Solver. I'm using the professional version. The Academy currently has the commercial version. We're in the process of upgrading to the professional version. Hopefully by the time you actually see this video, we'll have the professional version available for you to install on your computer. So, the advantage of Engineering Equation Solver is we can do a lot more analyses in a lot less time than having to look data up on tables, find the data, interpolate between two data points because we don't have every individual degree or fraction of a degree for saturated steam tables and pressure tables. So Engineering Equation Solver is also a modern, more accurate set of data that it uses for its source. So let's go ahead and get started. I'll be copying and pasting some things in to facilitate the process, and I'll talk about it. While you're viewing these videos, feel free to have Engineering Equation Solver open and pause the video at any time to enter the text and or data so that you can build your own Engineering Equation Solver program by watching this video. So initially I'll set up some basic things. A title, simple refrigeration example. For students, it might be your class and section, followed by your name, followed by the assignment. Anything in quotation marks is, double quotes, is a comment and will not be acted upon by the software other than to show it or not show it in formatted equations. A double slash at the beginning of a line is a comment that will not show up in formatted equations. And also the curly brackets are another way. Let me do one of these. So let me take this here. I'll delete those. And highlight this line. Right click, comment curly brackets. Those curly brackets will also comment out that particular text, and it will not show up in formatted equations. So this is nice, so you can have comments in your programs that you see when you're in the actual equations window, but for output to a more pleasing format, the comments are not included, so they're not distracting. It's a good idea to comment any program you make so that when you come back to it a year later or 6 months later or whenever, you can refresh your memory as to what you were doing and why you did it that way. So we have different directives. $ symbol precedes a directive. So $font space Arial space 14 is telling the program, and this is only available in professional. It's not available in the commercial version. So until you get the professional version, you can't do this. There are other ways. But it sets the font for the equation window at, and for the formatted equations, I believe, at 14 points, and Arial is the font. Tab stops sets when you hit the tab key, where it will stop. And the unit systems, you can have English or SI, Fahrenheit or Rankine for the English, Celsius or Kelvin for SI, PSIA for English, and there might be a millimeters of mercury, I don't remember, but we can look here. So any of these can be set up in advance. So you can have English can be mass or molar, Fahrenheit, PSI, or atmosphere, and degrees or radians. SI has a few more selections. and I typically stick with entering what I want as a directive at the beginning as opposed to using this function. Either one works. Notice that all changed blue because I'd gone out and then came back. It did a little miniature compilation and said, okay, blue is a color that they use for comments. Green is the color that's used for directives. And so that also helps when you're troubleshooting. So moving along, what we're going to do is create a heat balance of an R12 refrigeration system. The first thing we're going to do is just create a bunch of, or a table actually, of temperature, pressure, enthalpy, and entropy. Starting with basic information, we're going to use a system that's commonly found in U.S. Navy training manuals, and I'll copy it into the diagram window so you can take a look at it as we're going through this. So let me copy that, put it over here. So the diagram window, so these icons up here, if you hover over them, it will tell you what it is. So Control D is another way of getting to the diagram window. I already copied this file, so now I'll paste it, this visual. And you can see looks like some of the circles did not come through. All right, let me get those. See if this will help out any better. There we go. All right. That just helps the numbers stand out for our state points. We got 4 state points. The inlet to the compressor is a high temperature, high pressure, or low pressure temperature, sorry, low pressure, superheated vapor. On the high pressure side, it comes out of the compressor as a high temperature, high pressure, superheated vapor, goes through the condenser, exits, and goes into the receiver as a high pressure, high temperature, subcooled liquid, goes through the thermostatic expansion valve and changes over to the low pressure, low temperature, mixed fluid, liquid and vapor. So that's commonly found in many Navy rate training manuals where they talk about refrigeration. So we're going to take some basic information. Their version has all the data that they want to talk about already on there. They're not deriving it, they're not calculating it. They're taking it and just discussing what's happening in the process. We're going to do something a little different. And that's going to be starting out with some basic information. Steady state, steady flow conditions. The temperature of the refrigerated space, -5 degrees Fahrenheit. Superheat at the outlet is 10 degrees of superheat to prevent slugging the compressor. Discharge pressure, 141 psi. Discharge from the condenser is subcooled by 5 degrees. Thermal expansion valve is isenthalpic, constant enthalpy. Evaporator and condenser are isobaric. Constant pressure. Compressor is, I think I mentioned that, isentropic. Constant entropy. So we'll start with point 1. And I'll copy and paste some more items in. So let me look at formatted equations. This is what things look at when they're formatted. So notice the blue, the red is caused by this exclamation point. You put a single quotation, exclamation point, and then put your text in there, close the quotation. Everything between the two quotes will be in red. So you can make things stand out a little bit. Notice the items in the square brackets are subscripts. We're creating an array here. And I've got a section here commented out, and you can see in the formatted window Gotta select the right one. There we go. Notice it just goes from T1 to P1. These are skipped and the gap closed because it's enclosed. It's as a comment. It's commented out. So we're going to go ahead and comment those back in. And now we want to determine temperature, pressure, enthalpy, and entropy at state 1. T1 is the temperature at state 1, and all it is we've got this temperature at state 4, and that's at saturation conditions. So once it comes through here and we start adding some superheat, we add 10 degrees of superheat. That's what's going on here. So T4, we identify it as -5. Superheat added is 10 degrees Fahrenheit. Pressure at P1, we're ignoring all pressure losses, so P1 equals P4. Again, we're saturated vapor liquid conditions here, so for 0.4, P4, all we need is the temperature, and we're going to use R12. So our conditions are saturated pressure for R12 at T equals T4, which is -5 degrees. And then we need enthalpy and entropy. And you can see these are typed in. One of the easy ways to get that, you can type in whatever your property you're looking for, enthalpy, entropy, temperature, pressure, the way it is here. So you put whatever variable you want. It doesn't have to be H. We use the standard symbols though, H for enthalpy, S for entropy, equals enthalpy, and then in parentheses, your fluid, comma, temperature equation, temperature equals T1, P equals P1, and close the parentheses. If you want to, until you get familiar with that, and even if you do, you can go up here to function info, Control Alt F, or under options, function info, either one takes you to the same place. Go to thermophysical properties, and over here we've got all of the fluids that we have access to as real fluids. Notice it's a significant number, a lot of refrigerants, a lot of R12, R114, R134A. So we want to do R12, and we want to do enthalpy, and we had temperature and pressure, so temperature and pressure, but you only need two independent properties. And unlike the steam tables where you've got to look and do interpolations and like, if you've got temperature and entropy, you have to play some games to get pressure, right? So it's not all that straightforward. Here, the independent properties are listed, and you can use any of them. Any two independent properties can be used for this. The other thing you can do here is you can put in your subscript. So we put in a bracket, and this was for 1. Notice I put it in over here, and it puts it in, we want H1 is equal to enthalpy R12, temperature at T1, pressure at P1. And we can just paste it. Boom. Good to go. So I already did that. So we've got that. I'll delete that. You can do the same thing for entropy, any of the other properties that are in there. Let's just take a quick look. So we got enthalpy, we got entropy, you got CP, CV values. Some that we're not going to use too much. Internal energy we don't use a lot. Kinematic viscosity we'll use later on. Pressures, PSAT we used over here. And then just general pressure. So pressure, same thing. We need, so here they're looking for temperature and specific volume as the two independent variables. But you could use entropy if you liked. If you had entropy, you could do that. All right, so, and then you just paste it right in. It'll have all your subscripts and everything, very little editing to do. The other thing you can do, obviously, is copy and paste. Copy. Paste. and then edit. So you could change, all of these to 2 if you wanted. That's doable. We're not going to do that. We've got another way. We've got other things we're going on for that. But now we can also check a couple things. As you go along, you build your program, check it. You click the formatted equations. Does this make sense? T1 equals T4 plus T superheat. Great. T4, okay, that gives me that value. T superheat, that gives me that value. Solve for T1. Now we want pressure. Pressure 1 equals P4. We don't know P4. So P4 equals P sat, because it's a saturated fluid. And it's R12. Temperature at T4, that gives us pressure. Now we've got 2 independent properties, temperature and pressure, that we can use to develop the other properties, because we're no longer in a saturated condition at point 1. We couldn't do this at point 4 because point 4, we don't have 2 independent properties with temperature and pressure. They're not independent. So now we can also do a quick check and do a calculation. So this little button up here, solve, F2. First thing that comes up, we got superheat temperature, shows up here. Everything else is going to go on to our arrays. We got 2 potential units. What they're doing there is they said you don't have units put in for these yet. So we're going to go ahead to the arrays table, and we're going to say units, pressure, PSIA, okay, and temperature, we're going to say units of Fahrenheit. Excellent, good to go. And we also need enthalpy and entropy. Okay, so we'll do that. We'll select, we'll accept those, BTUs per pound. Okay, and here I'm going to change that to F, since the size of a degree Fahrenheit and the size of a degree Rankine are the same, and that's what's critical here. This precludes, sometimes you get some issues when you're dealing with Fahrenheit in one part of your units and Rankine in other. It's not really necessarily consequential, but it's better to keep it all the same. It makes life easier. So that gives us all of our 0.1 values. So let's go ahead and add in 2, 3, and 4. Copy and paste, and we'll do a formatted equations again. So we were looking for temperature, enthalpy, and entropy because we already had pressure at P2. That was given, as you recall. So now we've got to, but if we try to run this right now, we don't have a value for there. It's going to choke. Let's see what happens. Whoop. 16 equations, 18 variables, because I have these 2 commented out. But I have them commented out for a reason. What I want to do is, instead of putting them here, I'm going to put them in as input variables on this diagram window. So I will say I want an input variable. I want it to kind of stand out. So we'll go up to like, that's 14 point, that sounds good. We'll make it a reddish color, but that's a little too bright. I'll darken a little bit. Add it to my custom colors. I want it to be bold. Input variable, and we want it to be, we need P2. Okay. And I have to click off of that. If I go to add another variable with that selected, it will just edit that variable as opposed to adding a new one. So another input variable, and we want subcool temperature, how much subcooling we want. Okay, there we go. And I'm also going to go ahead and add in the T4 and T superheat so that I'll comment those back out again. So input variable, don't want to do that. Notice it's already selected that. If I go ahead and select one of these, it will change that. So I'll cancel that. Now I'll go ahead and add it back in. Input variable, we need T4. Okay. And one more. Click off of that. Add a new variable. And that will be T subcooling. Oh, no, superheat. T superheat. Okay. So we've got P2, subcooling temperature, T4, and T superheat. Those are all the known values that we have. Now I want to do some other things. I want to put all of our pressure, temperature, enthalpy, and entropy by each of the state points. So those are going to be output variables. So let's do an output variable. Let's start with pressure, and we want the color to be something different. We'll make it a nice dark blue. Okay. Not bold. Okay. So we'll put that down here. E1. And I want to edit one more thing. Show units. We got to show units, include variable. And we want to show it all the time, not just after calculations. It gets confusing when they start disappearing if you're not familiar with it. All right, so that's done. Now I want to add temperature. That's T1. Okay. Now, see what I did? I did what I told you not to do. I forgot to click off of it, deselect it. So I got to deselect that, go back. Now I can do output variable T1. Okay. P1, T1, H1, and S1, right? So now we want, almost. Now we want enthalpy, okay, and entropy. Entropy, output variable, bring it down. Entropy, S1, okay. That's a little bit spread out. I don't like that, and I think I do like bold better. So let me first of all, I'm going to bring this up a little bit. I'm going to select all of these. I'm going to select the properties, make it bold. Okay. And then I'm also going to do a little cleanup. You can do this in professional. I want the left slides lined up, and I want them spaced equally. So there, I tightened it up a little bit. Move everything over to the left a little bit with the arrows, get it off that fluid line there. Now I'm going to copy and paste. Paste once, twice, 3 times. And so that's one. And I think they're stacked on top of each other. 2. There should be one more there. 3. And now I just need to edit them. So P1 becomes P1, T2, H2, S2, P3, T3, H3, S3, last but not least, P4, T4, H4, and S4. And we're almost done. So I've got all of our variables. So notice P4 is here and, oh, sorry, T4 is here and here. Here it's an output variable, here it's an input variable. So we also need to fix this here. P2 has to be 141. And subcooling is 5. And one more thing I want to add here, go back to this, and we'll add a calculate button. And we'll put that right over here. That's a good spot. That's okay. So, now we go back, and we hit calculate. And notice a couple problems. One, these reverted to ones, but I have a value for P2 here, or actually for T4 here, and for superheat here, and here. So that's why, if you recall when we started, this was commented out. So T4, right click, comment it out. Now come back, 141, and this was 5, calculate, and look at that. So we got a whole nice little table here. And one other thing we want to look at is solutions. The only thing that's going to show up here are these guys that are not in the array. So for the array, we go to the array, and we've got all of our data. And it's very close to the data that's on the Navy manual books. And that's it for today's lesson. Thank you.